We'll start in 1 minute. We'll continue today in section 9.7 on graphing quadratic functions with transformations. And a reminder, 1 week from today, we'll have test 4. Later today, I will send the test 4 review sheet. Okay, let's do the next problem. We have this quadratic function, y equals negative 2x squared minus 8x minus 10. We'll write it in vertex form using the completing the square method. And we'll find the Y-intercept and the X-intercepts if there are any, and the vertex. So start out with the Y-intercept. When x is 0, the y-coordinate is negative 10. Now let's write this in vertex form. So when negative numbers are involved, it seems like you need to be a little more careful. We're going to factor negative 2 out of the x squared term and the x term. When we factor negative 2 out of the first two terms, inside the parentheses, we have x squared plus 4x. And then right parenthesis, and then put minus 10 on the outside. As always, whenever you're factoring, you can always check your factoring by multiplying. So at a glance, we can see that negative 2 times x squared is negative 2x squared, and negative 2 times positive 4x gives us a minus 8x. In the next step, we add 0 inside the parentheses. So now we're focusing on x squared plus 4x. For x squared plus 4x, we take 1/2 of 4 and square it. 1/2 of 4 is 2. 2 squared is 4, so we write plus 4 minus 4. Then in the next step, -2 times the perfect square trinomial, we're going to keep the x squared plus 4x plus 4 inside the parentheses, x squared plus 4x plus 4. And then outside of the parentheses, we're going to write what -2 times -4 is, which is +8, together with the -10 that's already on the outside. And then in the fourth step, we'll have the vertex form. We have y equals -2 times the binomial x plus 2 squared, and then +8 minus 10 is -2. Okay, so we can write down the x and y coordinates of the vertex. The x coordinate of the vertex is -2, and the y coordinate of the vertex is -2 also. To find the x-intercepts, replace y with 0 and solve for x. So replace y with 0 because every x-intercept has a y coordinate that's equal to 0. So we have 0 equals -2x squared minus 8x minus 10. Since we are solving an ordinary quadratic equation, the variable y has been replaced with a number. So now we can proceed to solve this equation. We are permitted to divide every term on both sides by -2. It's not required, but it will probably make the arithmetic simpler. So divide every term on both sides by -2. 0 divided by -2 is 0. And on the right-hand side, x squared plus 4x plus 5. Well, the trinomial cannot be factored with integer coefficients, so we can use the quadratic formula, where a is 1, b is 4, and c is 5. So we get x equals -4 plus and minus the square root of 4 squared minus 4 times 1 times 5, all divided by 2 times 1. Okay, then x equals -4 plus and minus the square root of some number, all divided by 2. Inside the square root, 4 squared is 16, and we're subtracting 4 times 1 times 5. 16 minus 20 is -4. Okay, well, what does that tell us? We were trying to find the x-intercepts, and after replacing y with 0, the two solutions for x are non-real numbers. So what does that mean about the graph of the quadratic function? It means there are no x-intercepts. But we could have known that earlier. This quadratic function, y equals -2x squared minus 8x minus 10, the leading coefficient is negative, so we know the parabola opens down, and the vertex is below the x-axis. So the parabola does not intersect the x-axis, so there are no x-intercepts. So there's an analytic way to come to that conclusion. The analytic way was trying to find the x-intercepts by replacing y with 0 and solving for x. Two non-real solutions tells us analytically that the graph has no x-intercepts. But then if we just graph the parabola, we'll find that there are no x-intercepts. So no x-intercepts. Okay, so let's see if we can find a couple of other points. Let's plot the vertex, -2, -2. And let's find a couple of other ordered pairs. So a strategy that I've used before, the x-coordinate of the vertex is -2. So in my table of ordered pairs, if I pick the x-coordinate of the vertex to be the middle value, and then pick an integer smaller than -2, such as -3, and then an integer larger than -2, such as -1, and then find the y-coordinates that correspond to -3 and -1. Then we can plot those 2 points and sketch the parabola. All right, when x is -3, we replace x in the function with -3. So we get y equals -2 times the number -3 squared minus 8 times -3 minus 10. Okay, so -3 squared is 9. -2 times 9 is -18. And then plus 24. So now we're up to +6. 6 minus 10 is -4. By symmetry, we can conclude that the y-coordinate that goes with -1 is also -4. But even if you don't recognize the symmetry, we can still find the y-coordinate using arithmetic. This time replace x with -1. So we have y equals -2 times -1 squared minus 8 times -1 minus 10. -1 squared is 1. -2 times 1 is -2. And then we're subtracting -8, which means the same thing as adding 8. So -2 plus 8 is +6. 6 minus 10 is -4. So just as we suspected, the y-coordinate for that goes with x equals -3 is the same as the y-coordinate that goes with x equals -1 because of symmetry. So plot those 2 points, -3, -4. And -1, -4. And then the parabola opens down. Okay, more of the same. So experts are made by doing things over and over again until, even though it's boring and tedious, that's how you get good at something, by doing it over and over again. So that's what we'll do today until time runs out. Y equals -3x squared plus 18x minus 27. Since finding the y-intercept is the easiest thing, let's find the y-intercept. Every y-intercept has an x-coordinate of 0, and when x is 0, the y-coordinate is -27. So the y-intercept is an ordered pair. It has an x-coordinate of 0, and in this case, the y-coordinate is -27. All right, now let's proceed to write the quadratic function in vertex form. All right, so we factor -3 out of the x squared term and the x term. So -3 times the quantity x squared minus 6x. Remember, we leave the constant outside of the parentheses, so -27 is on the outside. All right, that's the first step. If you looked at the quiz that's due tonight at midnight, you notice that the directions say in 4 or 5 steps, write the quadratic function in vertex form. So that's what we're doing here. We're doing it in 4 steps. This is the first step. The next step, we add 0 inside the parentheses. So this time the form 0 takes, well, now we're focusing on x squared minus 6x. 1/2 of -6 is -3. When we square -3, we get +9. So we add 9, then subtract 9. Then in step 3, we keep the perfect square trinomial inside the parentheses, the x squared minus 6x plus 9. And on the outside of the parentheses, we're going to put what -3 times -9 is, which is +27. So we write +27. And then we write the -27 that's already on the outside. And then the next step, the fourth step, this is the vertex form, y equals -3 times the binomial x minus 3 squared. And then +27 minus 27 is +0. We don't need to write the +0. It's okay if you do write +0, but it's not required. So I'm not going to write it, but we still know that the y-coordinate of the vertex is 0. The x-coordinate of the vertex is 3, and the y-coordinate is 0. Okay, the vertex is 3 zeros. So what does that tell us? Yeah, it's also the only x-intercept. So we don't have to search for the x-intercept since the vertex is the x-intercept. But we do need a couple of more ordered pairs. So we'll plot the vertex 3, 0 and label it 3, 0. And so another thing that we could use as to check our result, we know the parabola has to open down. So in our search for other points on the graph, if we pick other x values besides 3, we're expecting y coordinates that are negative, right? That's just a checkpoint if you do the arithmetic and come up with a positive number, then you can analyze the situation and realize, well, that can't happen. Something went wrong somewhere. Okay. So I'll use the same strategy that I typically use. The x-coordinate of the vertex is 3. So for the x values, I'll use 3 as my middle value. Then I'll pick an integer smaller than 3, like 2. And then another integer for x bigger than 3, such as 4. And we know that the y-coordinate that goes with 3 is 0. And by symmetry, the y-coordinate that goes with x equals 2 is going to be the same y-coordinate that goes with x equals 4. So let's find the y-coordinate that goes with x equals 2. So we use the function as a formula. We replace x with 2 and do the arithmetic, and that will give us the y-coordinate. So when x is 2, y is negative 3 times 2 squared plus 18 times 2 minus 27. 2 squared is 4. Negative 3 times 4 is negative 12. And then plus 18 times 2 is plus 36. So negative 12 plus 36 is 24. And 24 minus 27 is negative 3. And the y-coordinate that goes with x equals 4 should be negative 3, provided no mistakes were made. But let's go ahead and find the y-coordinate that goes with x equals 4 by replacing x with 4. So when x is 4, y is equal to negative 3 times 4 squared plus 18 times 4 minus 27. 4 squared is 16. Negative 3 times 16 is negative 48. Plus 18 times 4 is plus 72. So negative 48 plus 72 is 24, and 24 minus 27 is negative 3. So just as we suspected, when x is 2, the y-coordinate is negative 3. When x is 4, the y-coordinate is negative 3. And the parabola opens down. All right, let's move on to the next page. Well, I've sort of been slack on identifying the line of symmetry. So let's do that on here just as a reminder. The vertical line of symmetry, it's not actually a part of the graph. We think of it as an imaginary line, but still we need to know what it is. The vertical line of symmetry. What is the vertical line of symmetry for this quadratic function?
X equals 3.
Yeah, x equals 3. Notice it's not enough to say 3. We have to say x equals 3. In the xy plane, x equals 3 represents a vertical line where every x coordinate on that vertical line is the same number 3. Okay, the next page. So this is sort of like taking medicine. You just have to do it. Okay, y equals negative 4x squared plus 16x minus 8. The y-intercept is the ordered pair 0, negative 8. All right, let's get it into vertex form in 4 steps. So in step 1, factor negative 4 out of the x squared term and the x term. So we have negative 4 times the quantity x squared minus 4x. And then put the minus, leave the minus 8 on the outside. The next step in the completing the square process, the second step, is the adding 0 step. So x squared minus 4x, to create a perfect square trinomial, we take half of the coefficient of x and square it. So half of negative 4 is negative 2, and when you square negative 2, you get positive 4, so we write plus 4 minus 4.
So isn't the coefficient of x 16 in the original equation? I'm lost here.
Yeah, plus 16x.
So did you just skip directly to having that to the floor?
So you can check negative 4 times negative 4x is positive 16x.
Okay, I got it. Thank you.
Are we all okay now? Okay.
Just had a slow one.
Okay. Then in the third step, we're going to keep the perfect square trinomial, the x squared minus 4x plus 4. And so now you've got me wondering. I'm just checking. I think we're okay. Then on the outside of the parentheses, negative 4 times negative 4 is positive 16. And then minus 8. Okay, then we have y equals negative 4 times x minus 2 squared plus 8. Okay, let's find the x-intercepts, or are there any? Actually, why don't we write down the vertex first? The x-coordinate of the vertex is 2, and the y-coordinate of the vertex is 8. The vertex is above the x-axis, and the parabola opens downward, so there are 2 x-intercepts. Okay, so to find the x-intercepts, replace y with 0 and solve for x. So 0 equals negative 4x squared plus 16x minus 8. So with this quadratic equation, we are allowed to divide every term on both sides by negative 4. 0 divided by negative 4 is 0. And then divide every term on the right-hand side by negative 4. We get x squared minus 4x plus 2. Well, this cannot be factored with integer coefficients, so we can use the quadratic formula where a is 1, b is -4, and c is +2. So we get x equals the negative of -4 plus and minus the square root of the number -4 squared minus 4 times 1 times 2. All divided by 2 times 1. Then the negative of -4 is 4, plus and minus the square root of some number divided by 2. So inside the square root, the number -4 squared is 16, and we're subtracting 4 times 1 times 2. 16 minus 8 is 8. And we can simplify the square root of 8. I'll finish that up here. The square root of 8 is the square root of 4 times the square root of 2, and the square root of 4 is 2. And then we can cancel one factor of 2 from all of the terms in the numerator and denominator. So one x-intercept is 2 minus the square root of 2, and the other x-intercept is 2 plus the square root of 2. Okay, so we don't have a lot of space, so I'll make the intervals pretty small. So the vertex is 2, 8. One of the x-intercepts, we're supposed to write the x-intercepts as ordered pairs. So one of the x-intercepts is the ordered pair 2 minus the square root of 2, comma 0. And the other one is 2 plus the square root of 2, comma 0. The square root of 2 is approximately 1.4142. So 2 minus that is about 0.58. So 0.58 right in there. The other x-intercept, 2 plus the square root of 2, is about 3.41, so right in there. Okay, moving on. Oh yeah, the vertical line of symmetry is x equals 2. The number 2 is the same as the x-coordinate of the vertex. All right, the next one, y equals 2x squared plus 8x plus 4. I'll let you work on that for a few minutes. So you can identify by typing in the ordered pairs for the vertex, the y-intercept, and the x-intercepts. And then if you type those in, identify what you're typing in. So for example, the vertex is an ordered pair and so on. I get a different vertex than -3, 2. Okay, let's go ahead and go through this. The Y-intercept, when x is 0, the y-coordinate is 4. The vertex form, start by factoring 2 out of the x squared term and the x term. So it's 2 times x squared plus 4x. and then leave the +4 on the outside. And then in the next step, we add 0 on the inside. So we're focusing on x squared plus 4x. Take half of 4 and square it. Half of 4 is 2. 2 squared is 4. So we write +4 minus 4. And in step 3, 2 times the perfect square trinomial, x squared plus 4x plus 4. And then 2 times -4 is -8. So we write -8 with the +4 that's on the outside. The next step is the vertex form. Y equals 2 times the binomial x plus 2 squared. And then -8 plus 4 is -4. So the vertex, the x-coordinate is -2 and the y-coordinate is -4. Okay, the vertex, the x-coordinate -2, the y-coordinate -4. This is below the x-axis, and the parabola opens upward. So there are 2 x-intercepts. Okay, so to find the x-intercepts, replace y with 0 and solve for x. So we have 0 equals 2x squared plus 8x plus 4. Now that we're just solving an ordinary quadratic equation in the variable x, we can divide every term on both sides by the same non-zero number. So we'll divide every term on both sides by 2, and we get 0 equals x squared plus 4x plus 2. We can't factor this with integer coefficients, so we'll use the quadratic formula. We get x equals -4 plus and minus the square root of 4 squared minus 4 times 1 times 2, all divided by 2 times 1. And then we get x equals -4 plus and minus the square root of 16 minus 8 is the square root of 8, all divided by 2. The square root of 8 is 2 times the square root of 2. So when we cancel the common factor of 2's, we'll get x equals -2 plus and minus the square root of 2. Those are the 2 x coordinates of the x-intercepts. Okay, let's go ahead and sketch a mini graph. So -2, -4. And the parabola opens up. Okay, so -2 minus the square root of 2 is, it's about -3.4. And then -2 plus the square root of 2 is about -0.59. And we can plot the y-intercept finally. The y-intercept is 0.4. So here's our rough sketch of the parabola. Using symmetry, we can find a point on the parabola that corresponds to the point 0,4. Since the x-coordinate of the vertex is -2 and the x-coordinate of 0,4 is 0, by symmetry, the ordered pair -4, 4 is also a point on the graph. Okay, let's work on the next one. Y equals -2x squared plus 12x minus 16. Okay, the y-intercept, when x is 0, the y-coordinate is -16. Then we'll get it into vertex form. Factor -2 out of the x squared term and the x term, so we get y equals -2 times the quantity x squared minus 6x, and leave the minus 16 on the outside. In the next step, the second step, we add the 0 inside the parentheses. So now we focus on x squared minus 6x. We're going to create a perfect square trinomial, so we take 1/2 of -6 and square it. So we add 9 and then subtract 9. Then in the third step, we have -2 times the perfect square trinomial, x squared minus 6x plus 9. And from the second step, we apply the distributive property by multiplying -2 times -9, which is positive 18. So we put plus 18 on the outside of the parentheses, together with the minus 16 that's already on the outside. And then in the fourth step, we can write the vertex form, -2 times the quantity x minus 3 squared and plus 2. All right, so the vertex is the ordered pair +3 for x and +2 for y. Okay, let's find the x-intercepts. To find the x-intercepts, replace y with 0 and solve for x. So we get 0 equals -2x squared plus 12x minus 16. Divide every term on both sides of the equation by -2, and we get 0 equals x squared minus 6x plus 8. So finally, we get a quadratic equation that can be solved by factoring. The two factors of x squared minus 6x plus 8 are x minus 2 and x minus 4. So the x-intercepts are the ordered pairs, 2, 0 and 4, 0. When there are two x-intercepts, notice that in all cases, whenever there are two x-intercepts, the x-coordinate of the vertex is always halfway between the x-coordinates of the two x-intercepts. Just a useful observation. It's the symmetry of the parabola at work. Do you see what I mean? The x-coordinate of the vertex is 3. The two x-coordinates of the x-intercepts are 2 and 4. And 3 is halfway between 2 and 4. So I'll try to graph this. So the ordered pair 3, 2 is the vertex. We know the parabola opens down because the leading coefficient is negative. And one x-intercept is 2, 0. And the other x-intercept is 4, 0. And then the parabola opens down, so this is roughly the graph of the parabola. Well, we still have a few seconds left. We can at least start this one. The y-intercept is 0, 4. Okay, it's 8:50, so it's time to quit. You can go ahead and sign in for attendance.
Have a good weekend.
You too.